Hi, my name is Grace Esshalina Misak and I'm from UITM Cawangan Sabah, Campus Kota Kinabalu. I'm in group 8110182 and this is my video for seed germination. Seed is a small embryonic plant enclosed in a covering called seed coat, usually with some stored food. It is developed from the fertilized ovules. Seed respire slowly, consume oxygen, produce carbon dioxide and water. There is two types of seed, monocotyledons and dicotyledons. Dicot seed have a thin seed coat. It has hilum and micropyle, which is visible on the surface. If the seed coat is removed, the two large food-storing cotyledons are visible. Dicot seed has two cotyledons, epicotyl, hypocotyl, and radicle. Monocot seed is a one-seeded fruit. Seed coat are membranous and fused with the fruit wall. Embryo consists of one cotyledons, plumule, epicotyl, hypocotyl, and radicle. Cotyledons transfer food from the endosperm to the embryo. Germination is a process in which seed emerges from the period of dormancy and a plant grows from the seed. It requires a light temperature, moisture, oxygen, and nutrients. Emergence of radicle and plumule through the seed coat. During germination, testa split open and the embryo plants start to grow out. There's two types of germination. One is hypogel. Hypogel germination occurs in most of monocot plants. The cotyledons remains on the ground inside the soil. Cotyledons play no role in photosynthesis. Elongation of epicotyl to raise the first leaves out of the soil. Terminal part of the epicotyl is curved to protect the plumule from friction. In hypogel germination, seed absorb water cause seed coat to swell. Radicle grows down and the first internode and epicotyl grow up. The new leaves form and start a food production. New root system develops above the first internode, just beneath the soil. Radicle dies after permanent roots is formed. Epigel germination occurs in most of dicot plants. The cotyledons emerge out of the soil or above the soil. Cotyledons turn green to photosynthesis and act as first leaves of the plant. Greater elongation of hypocotyl and terminal part of hypocotyl is curved to protect the plumule from friction of the soil. In epigel germination, seed absorb water cause seed coat to swell. Radicle grows down. Hypocotyl elongates and reach light. Hypocotyl straighten up, pulling cotyledons out of the soil. Cotyledons turn green and manufacture food until new leaves develop. As new leaves develop, cotyledons dies, dry up, and fall off. To seed germinate, it requires water. Mature seed have relatively little moisture to prevent decay. To germinate, seeds must take in water. Uptake of water by seed is called imbibition. Imbibition leads to the swelling and the breaking of the seed coat. Secondly is oxygen. Oxygen is the presence of enough moisture causes respiration to start metabolism. This creates energy for the germination process. Respiration rates for germinating seeds are very high, therefore adequate oxygen is necessary. Seed beds that are overwatered or poorly drained will cause the oxygen supply to become limited, so the germination percent will diminish. Next is temperature. Most seeds go through a cold period before germination. This helps prevent seed from sprouting as soon as they mature. Most common annual vegetables have optimal germination temperatures between 24 until 32 Celsius. Lastly is light. Generally, seeds require darkness to germinate, but sometimes it requires light. Photoblastic is seeds respond to light for germination. Three categories of photoblastic seeds. 1. Positive photoblastic, which is lettuce, tobacco, and mistletoe. These require exposure to sunlight. Second is negative photoblastic, which is onion, lily, amaranthus, and nigella. These do not require exposed to sunlight. 3 is non-photoblastic. This is non-exposure to light.